This is where we left off in the previous video. This is the unit circle with radius 1 and the origin as the center. This length was sine theta, this length was cos theta, and the length of this tangent was tan theta. To understand the relation between the angle theta and the functions, let's try changing the angle theta. Let me redraw the figure on a new page. This length is cos, this length is sine, and this length is tan. I'm not writing theta next to every function as we're doing this just for our understanding. Now let's try increasing the angle theta and see what happens to sine, cos, and tan. Let's try increasing theta first. You can see that theta is increasing, and with it, you can also see sine increasing. And cosine decreases as theta increases. Look what's happening to tan. Yes, it increases along with theta. What happens when we decrease theta? Sine is decreasing, cosine is increasing, and tan is decreasing. The radius remains constant in each case. Now that we have an idea, let's look at 4 different figures with varying theta measures. This is how the figure will look if theta is increased. We have just increased the measure of this angle and kept this one at 90 degrees. Now let's analyze the change in the lengths. The hypotenuse will remain 1 unit as it is a unit circle. This length is sine theta, and we can see that it is increased in length as theta increased. This length is cos theta. We can see that this length decreased as the measure of angle theta increased. And since this point has moved upwards, the length of tan theta has also increased. What did we observe? As theta increased, sine and tan increased, but cos decreased. Now let's try increasing the measure of theta even more. This is how it will look. The hypotenuse still remains 1 as it is a unit circle. Sine has increased even more, and cos has decreased again. And the length of the tangent has increased as this point has moved further up. So again, as theta increased, sine and tan increased while cos decreased. What if theta becomes 90 degrees? Yes, the triangle won't exist. It will look something like this. This length will be sine theta. If theta is 90 degrees, then sine theta will equal 1 unit as it becomes the radius of the circle. Cos theta becomes 0 and tan cannot be defined in this figure. So the unit circle tells us that as theta increases, sine and tan increase while cos reduces. What we just learnt is valid for the first quadrant of the Cartesian plane. But you can apply the same concept to all other quadrants. There is another important result that the unit circle gives us. Observe all the triangles. They are all right triangles. So according to the Pythagoras theorem, the hypotenuse squared will equal the sum of the squares of the other 2 sides. The hypotenuse squared in every case is 1 squared, which is 1. And the other 2 sides in every triangle are sine theta and cos theta. Hence we can say that sine theta squared plus cos theta squared will equal 1 squared, which is 1. It is written as sine squared theta plus cos squared theta equals 1. This is considered one of the most important trigonometric identities which was derived easily using a unit circle. Doesn't matter what the measure of theta is. Sine squared theta plus cos squared theta will always equal 1. Many people have a lingering doubt in their mind when they study this topic. What if the radius was 2? Will this still work? The answer is yes, it will. Let's assume the radius was 2. So OB would be 2 in this case. Sine theta would be AB by 2 and AB would be 2 sin theta. Similarly, OA would be 2 cos theta. Using the Pythagoras theorem, we can say that 2 sin theta the whole squared plus 2 cos theta the whole squared will equal 2 squared. Dividing the entire equation by 4, we will get sin squared theta plus cos squared theta equal to 1. It doesn't matter what the radius is. This will always be true.